This is TechSNAP, episode 352. Hi everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on January 21st, 2018. This episode is brought to you by our three great sponsors, IXsystems, Ting, and DigitalOcean. I'll tell you about them as the show goes on. My name is Chris, and joining us every single week is our host, the admin, the tech, and the presenter, Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello, Chris.
Hello, Wes. We have much to get into this week. I'm really looking forward to today's episode, but we're going to kick off by answering a common question into the show. Is it a good idea to leave my RDP port exposed to the internet? It sure is awfully convenient. Well, today's story suggests that perhaps it's not a good idea.
No, it's not. And as a result, the SamSam ransomware group seems to have gotten off to a great start this year, hitting several high-profile targets such as hospitals, city councils, and industrial control systems. Yeah, that's right. Reported attacks include the one against the Hancock Health Hospital in Greenfield, Indiana, another hospital in Decatur, Indiana, a municipality of Farmington, New Mexico, and a number of cloud-based EHR systems.
Yeah, electronic health record systems, Allscripts being one of the larger ones. The Hancock health officials, though, this is interesting. They admitted to paying the ransomware despite having backups. Don't know why. The details aren't there, but I guess they still paid it, claiming they had backups.
Yeah, it sounds like kind of standard ransomware, just in that victim said they had locked files and a message that said, sorry.
Sorry. So the SamSam ransomware, which is also known as Samus, is not like just stock ransomware that's spreading like crazy. Apparently, the group custom targets each strain for the particular target.
Yeah, they scan the internet for computers with open RDP connections and then break into the networks by brute forcing those RDP endpoints. And then from there, spread across the network.
So it's not like a vulnerability necessarily in RDP. It's more like poor password practices, and they collect enough of them. And then once they get on the network, then they just go for it.
Yeah, exactly. You might see, if you're a victim, 000-sorryforfiles.html.
Sorry for files.html. Also, some victims reported files encrypted with the .weaponize extension. But you know what the worst thing is, Wes? It's actually kind of successful. They've actually made some money.
How much?
About $300,000. The count currently holds 26 Bitcoins, which are valued, well, it depends on the value of Bitcoin, right? So it depends. But when we did the research, it was $300,000. And it's apparently still getting transactions. So people are still paying the ransomware.
Yeah, it's a delicate trust scenario here, because even if you do pay the ransomware, 99% of the time you end up having to run some software that the attackers wrote. If this happens to you, you'll definitely, try to get your data back. Have backups is really the answer. But whatever you do, at the end of the day, you're going to need to reinstall your system. It just can't be trusted anymore.
That's a great point. Like, these are the jerks that got you screwed in the first place. So how can you trust them?
They have some incentive to at least give you back your files, just to have a general trust that people will pay them at all. But who knows what other further malware they could be leaving behind.
Yeah, and rootkits or anything that thing could be installing.
Right?
And you're going to give it all kinds of permissions to get your data back, even if it asks for administrative privileges. Yeah, that is awkward. And that one health organization said they had backups, but still paid the ransom. I would never do that. If I could avoid it, I would always go to backup, so that way you don't have to run that untrusted code.
Yeah, and you're not giving money to your attackers.
But regardless, I think this story stands as a warning, as maybe a reason not to have remote RDP connections listening to the internet. Really, though, if these companies had just secured their RDP systems with a strong and unique password, they wouldn't have gotten into the systems to begin with, because it wasn't a flaw in RDP. It was just a bad password.
Exactly.
But while we're talking about RDP, Microsoft's remote desktop protocol, why don't we talk about RDP hijacking, which is a different kind of attack. It's sort of like an abuse of some of the RDP powers.
If you've used remote desktop before, you've probably seen that you can connect to someone else's session, right? So if I've got your user account credentials and you have a session going, I can connect as you.
It's a very useful administrative tool.
Yeah, it's used all the time. The key there being normally you need to know that user's passwords. With this technique, that's no longer the case. Now, we should be clear, this isn't some, vulnerability that you can use to by itself get root access to a machine. But if you already have root access to a shared machine, this is a method that lets you become another user, appear to be another user, and therefore conceal your attacks, further attacks on the network.
Yeah, or if you were an insider who wanted to do something malicious before you bailed on a company and wanted to do it under the guise of a different user, this is how you would accomplish that work. This, I think, is probably the most common attack vector, is someone who works there and knows that they want to do something and they want to do it as somebody else.
Basically, here's the deal. If you run tscon.exe as the system user, which many of you will recognize as the built-in super powerful account underlying a lot of Windows tools, you can connect to any session without a password.
Say again?
Yeah, any session without a password. It doesn't prompt, it just connects you to the user's desktop. Currently, the researchers believe this is due to the way session shadowing was implemented in Windows, but it runs throughout the years like this.
Yeah, yep, it does. And it's again, a useful tool in some cases. Again, it's not about the system account. It's not about abusing the system account. It's about that the system account can then connect in and act as another user, represent as another user, essentially possess another user account.
Right, exactly. And so it becomes a really good way to conceal yourself and then jump from system to system. So once you've taken over one vulnerable machine, if an admin on the network logs into that machine, then you can abuse some of these, log in as him on the system, connect to other systems, and further propagate.
It's not just terminal services, though. This actually does work for physical consoles. You can hijack a screen remotely, and it will unlock the physical console if you, again, are using the system account to do this.
Yeah. And you can connect to any session. So for example, it's the help desk, you can connect to it. If it's the domain admin, you're in. Because of this point, it makes it super simple to laterally move throughout the network. Plus, there are no external tools needed, right? You don't have to try to install some weird malware or Trojan. These tools already exist. So once you have system access, that's all you need.
Yeah, it's funny. You could argue that these are also just legitimate administration tools that are built into the terminal services or remote desktop, whatever you want to call it, infrastructure of Windows.
Mm-hmm.
Session shadowing, for example, I use the crap out of that. It's a great way to troubleshoot remote users' desktop that are maybe logged in through terminal services, and you can just see everything they see.
They're doing.
I also would frequently use Task Manager to kill other users' processes that were hung. You could say, look, that's malicious, but it's very useful.
Yeah, totally.
But it's that level of integration. If you know how to get into a system, so say you have an RDP system exposed to the internet, and you know how to work and move through a system once you're at that level, it can be abused significantly.
Some recommendations about what you can do to try to mitigate this technique. One, strongly recommended that you use group policy to log off disconnected sessions. Now, this may not be popular, but it's definitely the secure way to go. Also, probably log off any idle sessions as well. And of course, don't expose RDP to the internet. And if you do, strongly suggest that you implement multi-factor authentication if possible. Really anything you can do if you're forced to have remote access available to keep that endpoint secure. Allow only the users that need to log in, multi-factor, strong password requirements, the whole lot.
DigitalOcean.com. Create an account and then use our promo code SNAPOcean for a $10 credit, and then play around with some of their systems and get a sense for how great DigitalOcean is. You can get a system spun up in less than a minute, and you can deploy applications on top of that or start with a base system. They have an easy-to-use control panel and an API that lets you spend more time coding and less time managing your infrastructure. You can seamlessly deploy infrastructure and scale it as you need, deploy pre-built apps, or just do something from the ground up. It's secure, it's scalable, and you can monitor it. They have built-in monitoring metrics and alerting. DigitalOcean.com. Use our promo code SNAPOcean. There's over 150,000 businesses on DigitalOcean. Lots of great open source communities are on DigitalOcean as well. And I point you to this rather handy guide, how to use DigitalOcean's API with Ansible 2.0 on Ubuntu 16.04. And they have guides for other distributions as well, like CentOS. Check it out at DigitalOcean.com. Really great documentation, even better prices. They just recently changed their pricing structure and how much memory you get. With data centers all over the world and easy to deploy applications, it's never been a better time to get started. DigitalOcean.com. Use our promo code SNAPOcean. Well, it has been a busy week, like I said, and that means, as always, we have some Android malware to talk about. We choose rather picky which ones go in the show.
Yeah, that's for sure.
But this one caught our attention because it's a secret hacking group that's using Android malware to spy on thousands of people across 21 countries.
Yeah, this is new research. With the combined efforts of the EFF and Lookout, the group's nicknamed Dark Caracal, and it uses custom Android malware included in fake versions of so-called secure messaging apps like Signal and WhatsApp.
They even implemented support for two-factor authentication codes, and it can collect other kinds of information from users' mobile devices.
And of course, the malware also let the group activate the phone's front and back cameras, as well as its microphone, to surreptitiously photograph or record a target.
They also use the FinFisher software, which shows talked about in the past. It's a surveillance tool, which is more commonly used by law enforcement and governments.
The researchers traced Dark Caracal's activity to the building controlled by the GDGS, one of Lebanon's intelligence agencies, by tracking down devices that Dark Caracal used to test its malware. Lookout and the EFF found that the test devices appeared to be clustered in the Beirut building.
Oh, Wes, we got a spy novel going on
I think
now.
we do.
Yeah. I think it's funny how the EFF set up camp and monitored these guys since July of 2017. And they determined that the group was running 6 unique campaigns. Some of which have been ongoing for years, and they had a wide net of targets, like military targets, government officials, medical practitioners, education professionals, academics, commercial enterprise targets. They just had a wide range that they were going after, and they were doing it by spying on them via their Android devices. So these people thought they were using like WhatsApp securely, and they're using a fake version, even though it's supporting two-factor, it's sending them text messages. It's just sitting there spying on them, turning on their microphones.
Yeah, that's kind of one of the interesting things about this attack. It's not super sophisticated or expensive. Instead, users installed these applications willingly and gave them the requested permissions that they used to spy on the user.
Yeah. I mean, in some cases, they clicked on phishing links that came in via email, like get the new Facebook Messenger, and so they clicked that. But it wasn't some sort of sophisticated zero-day flaw. It was the user installed it and said yes to the permission screen.
Good old-fashioned social engineering.
Wes, when I say networking equipment, the first name that comes to mind is probably not Lenovo.
No, it's not.
But they do have some news this week. Lenovo engineers have discovered a backdoor in one of their switch firmwares.
Yeah, Lenovo says that backdoor affects only rack switch and blade center switches running ENOS, the Enterprise Network Operating System. The backdoor was added to ENOS in 2004 when it was maintained by Nortel's Blade Server Switch Business Unit, or the BSSBU.
As we say.
Lenovo claims Nortel appears to have authorized... Here, say that again. Lenovo claims Nortel appears to have authorized the addition of the backdoor at the request of a BSSBU OEM customer. In a security advisory regarding the issue, Lenovo refers to the backdoor under the name of HP Backdoor.
I wonder if that's an indication of which customer asked for that backdoor.
Maybe it is.
So just to make sure this is clear, Lenovo didn't implement the backdoor. It was Nortel that implemented the backdoor back in the day when this was their business, and apparently a customer who may be named HP came knocking and said, we want this. And the backdoor has just remained in the code since probably about 2014. And what's funny about this is secondhand now, because IBM also owned this division for a bit before Lenovo bought it.
Yeah, it's an interesting trading of hands of this switch technology.
And the code has just stayed in there the entire time, Wes.
Yeah, the so-called HP backdoor, it's not a hidden account, but an authentication bypass mechanism that occurs under very strict conditions. Rack switch and blade center switches support various authentication methods: SSH, Telnet, a web-based interface, and a serial console.
Sure.
Only under a certain combination of authentication methods and security settings does this backdoor work. So if you're curious, if you have the Effect technology, go check out their security advisor for more details.
Yeah, I don't think these are super popular switches, but I will say they seem to be pushing out patches for even really old versions of the switch. So we got to give them credit. They're going way back to the older models too that maybe haven't been getting updates normally and pushing out updates. So you can check. It's also CVE 2017-3765 for you hip kids that like to look up the CVEs.
Thanks, Chris.
Let's do a quick Spectre and Meltdown update on the show. There's a batch of news this week, and there seems to be a theme. It's instability.
That's right. Now Intel says the current firmware updates that are now recently available may be causing computers with newer chips to reboot more frequently. Intel VP Navin Shenoy said firmware updated PCs with Ivy Bridge, Sandy Bridge, Skylake, and even the most recent Kaby Lake processors are all affected.
That's a lot of lakes.
That is a lot of legs and a lot of problems.
They've also noted that some of the problems that people are experiencing after some of these updates are more widespread than previously reported. AMD also issued a processor security update on their site, and they said, yep, we are vulnerable to variant 1 and variant 2 of Spectre, and yep, we do have to ship microcode to fully address it, which is a reversal of a previous position where they had said it would all be addressable via operating system updates and operating system updates alone.
Not all bad in the world of AMD, though. Previously, Microsoft had suspended shipping Windows patches to some AMD systems after similar unbootable system concerns. That's now been partially lifted, and updates are rolling out to modern AMD systems.
On Friday, after the show last week, VMware pulled their patches for Spectre and Meltdown, saying that there was some recent instability reported, and they recommend VMware users that run ESXi do not install the CPU microcode and patches at this time. If you're a VMware server user and you want to know more, go to techsnap.systems/352 and find the link in there. We have the details.
On the mitigation front, a set of Spectre mitigation patches for the GNU compiler collection, specifically for CVE 2017-5715 or Spectre Variant 2, were accepted to the mainline and will be part of GCC 8 with the GCC 8.1 stable release that is due out in March.
And there appears to be a bit of an effort to backport it to GCC 7 as well, which could be a good thing. And speaking of mitigation, Linux users got another tool to check to see if their systems are vulnerable. If you're running a current upstream Linux kernel, Greg KH blogged this week that you can grep/sys devices systems CPU vulnerabilities *, and you'll get back a return of if your kernel is properly mitigating Meltdown and Spectre vulnerabilities. It's kind of nice. He also kind of makes a dig that if your kernel doesn't do this, then it's probably time to upgrade.
A good reminder for everyone.
Then there's this story that I think both you and I kind of suspect is bogus, but it's skyfallattack.com that's trying to ride the hype train of Meltdown and Spectre, and it says that there's more attacks on the way and to keep an eye on this page. But I don't know, Wes. It's just sniffing as hype to me right now. The TechSNAP program is skeptical.
I think that's on the nose.
IXsystems.com/TechSNAP. Go there to learn more and support this show. There is one storage and server vendor in the world that Wes and I trust our systems to, and that's IXsystems. Learn more at IXsystems.com/TechSNAP. They got solutions for big data, cloud development systems, education systems. They'll build computers that meet the specific needs of finance or government or healthcare or manufacturing, and they have some of the best solutions for large virtualization loads. Now, we have the FreeNAS Mini here. I think I've been a customer for about 5 years now. We have the FreeNAS Mini currently in production. They'll custom build a server for any use that you have, though, if it's storage or not. If you do need dedicated storage, check out their TrueNAS product line. And if you need a whole rack of gear, check out the TrueRack. IXsystems.com/TechSNAP. And while you're there, I'll just give you a little plug here. Go have a read. OpenZFS versus ButterFS. It was posted quite a while ago, back on August, but it's such a great read, and you can find it on the IXsystems blog, IXsystems.com/TechSNAP. I approach his office in the busy downtown streets of Seattle, and I see on the front door, Wes Payne, problem solver. I open the door, I go in and I sit down, and I have a consultation with the man who's going to solve my problem, my woes, my configuration nightmares. It's something that we've hinted at on this show, that we want to talk about configuration management. It's something that I am struggling with, and it happens to be something that Wes uses in production every single day and has been reflecting on a lot recently. I have a feeling it's going to come up a lot more in this show. So why not cover a little bit of the basics today? So right here in episode 352, it'll be our introduction to configuration management. So later on in the year, we can dig much further into this, and this can be your starter guide, and hopefully it'll be a great source of information for me too.
I guess we should start with why you'd want to use it at all and what sort of problems it can solve.
Yeah, and I would be curious from obviously a server context, but maybe just from a desktop context too, like a workstation, a work machine context, how we could make this applicable for people that just have regular desktops as well.
Right. I mean, I think a lot of people, when they think of configuration management, they think of, fleets, thousands of servers that need complex configurations kept all in sync at the same time. And That's definitely one valid use case.
Yeah.
But it can be really useful even just for, your home Linux user.
So what's the core problems that configuration management is going to solve for me?
I think really the central idea is that all of your configuration, maybe not all, but at least most, is kept in version control, right? So you have this one central repository that all of your systems can be configured from one place, and it's written out. A lot of these systems are pretty declarative, and so it ends up being like, for systems that have this purpose, they have these systems installed, they have this configuration, and they have these packages.
I group machines, I categorize them. This is a server of this class, like maybe it's a database server. This is a web server, or this is a recording production system. This is a presentation system. This is a workstation.
Right, but it could even be something like, this is my work desktop, and this is my personal laptop.
It seems like one version of configuration management in this scenario could just be copy off all of your .configs and most of your etc config directory, maybe toss it in a Git repo or rsync it to a file server on your local LAN, right. And then just, you reinstall your box and you blast back your config files. Is that technically configuration management?
I would throw in a list of all installed packages so you could restore that too. But yeah, pretty much that's the basic. And if you just had a couple of machines, especially if they were all, exact copies of each other, that would work. So one thing people do as maybe a simpler option of configuration management is having base images where you've copied one machine, you've copied it to all of them so they all have the same running config. Configuration management just adds additional layers on that where one, your config is kept somewhere where you can reference and look at and track and audit, and it allows you to make more dynamic configuration changes as the systems are live.
I think what appeals to me, and I'm pretty sure you use this in your day job, is I want to deploy X kind of system, and maybe it's a Skype machine, or it is a standard test workstation, and I just want to plug a machine in and have this entire configuration blasted to it. I know a lot of developers will use this too. I just want to test this application. I want to select this and have a machine created for me.
Yes, it can be immensely useful for that. And you can have a lot of safety. When you have a system running and you run your configuration management software, it reports that it's changed everything to how you want it to be configured. You know that when you rebuild that system, all those settings, everything that is under configuration management control is going to stay exactly the same. So you can blow it away, build a new one, exactly the same.
Now, I know from my research, there's going to be really kind of two core types of configuration management systems, the kind that use agents and the kind that don't have agents.
Yeah, exactly. There's several axes you could use to divide configuration management. Another one would be, how high level or not. Some systems give you a little higher level look and show you less of the underpinnings of just how that configuration gets affected. Whereas some systems allow you to break out of the carefully designed environment and make some lower level changes yourself when you need to.
I see.
One of the first systems on the market, Puppet, is a good example of an agent-based system, another one being Chef. And so in an agent system, you typically have a central server, maybe a couple servers in HA running that act as data collectors. And then every node that you're running, each computer, your laptop, all your servers, they run an agent. And the agent runs usually on a schedule, maybe every half hour, something like that. Each time it runs, it collects a bunch of information about your machine. It goes and talks to the server and requests, hey, what am I supposed to be doing? And it gets its list of instructions to run. It then runs those instructions, looks at the system state, looks at its instructions, and goes and turns the system into exactly the state that you've specified. And then it goes and sends details about that run back to the central server. And so there you get the central server. A lot of times you can pay extra, get fancy UIs, dashboards to manage it.
Right.
And then it has a bunch of information about all the packages, current state of your system.
In my experience, the systems with agents tend to be a little more capable, have a little more features. They might give you cooler graphs or have more authority on the system. They can maybe more easily install or remove updates or even roll back updates if they don't conform to the norm. That was my experience with agent systems. It seems like I have more power, but then I also have to have a base OS and I have to install the agent, and that's also another potential attack vector.
Yes, you do. You do need to bootstrap the agent, which does include security considerations. Usually, you need some sort of secure token to auth the agent, or use your own authentication to the server to say like, hey, yes, I'm a trusted admin who's adding this node. It's not just a rogue node trying to join our cluster. one of the advantages that you're speaking of is, when you have an agent that runs every 30 minutes, you know that there's not going to be any drift on your system, right? No, even if someone comes along and makes a change, some, well-intentioned admin user,
It could walk it back.
It could walk it right back.
Now, not all systems that have agents actually require a central server, do they? Like, don't some, it's an agent, but it's almost like a self-contained agent that isn't sending off to a remote server. It's doing all of the stuff. It's doing all of the stuff locally, essentially.
Yes. So a lot of these systems, I know Chef does, I believe Puppet does as well, they have modes where you can run them standalone, where you just sort of like go fetch whatever configuration you want from GitHub, download it to the machine, and just run the agent locally. It parses that, then makes all the changes that you've requested. There are a lot of advantages to this, right? It lets you, it's a lot less setup. It's one server you don't have to run. You don't have to have internet connectivity to the server all the time. The downsides are it's a little harder to manage, right? Now you're going out and you're doing that on the nodes. And when you want to make a change, you have to go touch the nodes. Whereas if you let the agent talk to the server, let's say I want to upgrade the recipe that runs on our video streaming boxes here at JB, right? I don't have to go touch those boxes. I make that change on my workstation. I push that new recipe up to the server. And then those nodes, next time they run, they'll just fetch the latest code.
That is my preferred way to do it. Until you had said that last, but I was almost wondering if it would just be simpler for Jupiter Broadcasting to go agentless. But that sounds pretty compelling to be able to sit back and centralize that.
Yeah, it definitely has its advantages if you're willing to pay the infrastructure cost.
All right, so let's talk agentless. That seems like maybe best of both worlds. I still have centralized configuration, but doesn't essentially everything just work over SSH in most cases?
Yeah, a prominent example of an agentless system is Ansible. And Ansible leverages existing SSH servers that are probably running on your boxes.
Yeah.
Or
your entire SSH authentication infrastructure.
Yeah, exactly.
Keys or SSH.
LDAP or whatever it might be. So that can be really handy. You probably have SSH set up already. Ansible works. You define some YAML files that are tasks and playbooks.
Easy to read.
They're pretty easy to read. They're high level declarative. You say something like, "Hey, I want these packages installed, like these DNS servers configured."
It figures out all of the.
Figures out like, okay, well on CentOS that's files over here, but on Debian it's on this system. So that's another advantage of configuration management systems is they usually have those middle-ware abstractions for you, so that instead of having to write 6 different things for your 6 different distributions, you can write something that handles some of the low-level differences. You usually run Ansible from one sort of centralized server, or maybe it's your main workstation. You have an inventory file, and an inventory file defines all the hosts that you want to go connect to over SSH, and then you run Ansible, and you can have different groups of nodes, and you can say which playbooks they're going to run. And so much like in an agent system, you can divide nodes by class and category and role. The difference here being is that you then actively initiate an SSH connection. Ansible runs, goes and talks to each of those machines, runs all the commands that you want, and then disconnects. And there's no agent, nothing's left behind.
Right.
You do need Python to exist on the node itself, but that's included in a lot of bases these days, so that's not a big requirement.
To me, it sounds like I could get started with agentless a lot quicker because I could just point it at my systems, give it the SSH login, and let it go, right?
Right. I mean, all you need is, bring in a laptop, connect it to the JB network, and as long as you can SSH to the host, you can control it with Ansible.
So Ansible definitely sounds higher level, much more declarative. It's got the YAML files that are easier to read, for me particular, and it sort of fuzzes out the differences between, say, CentOS and Ubuntu LTS.
And you'll get that with a lot of systems, and they all aim to be declarative to a degree. Perhaps an example of the difference is, so Ansible uses YAML configuration syntax to define how you would like the host to be set up. If you'd like to add new functionality, you're going to write a library in Python, and that will expose some new YAML syntax, right?
I see.
Versus Chef uses a Ruby DSL, or domain-specific language.
Okay.
And so you're actually writing Ruby code in Ruby files, and a Ruby runtime is running and interpreting that.
Okay.
So they've made a bunch of helpers, right? Predefined objects and methods that allow you to do things like install packages on a system, and they have the same kind of wrappings for CentOS or Debian or what FreeBSD, what have you. The difference here is if you want to break out and just run some Ruby code, you're already running Ruby code. So it's a lot simpler to then kind of muddy the waters, break out of that declarative style, and just run regular old system code. That has upsides and downsides. I would say for more experienced developers, people who want to be writing code, who want a little more low-level control, Chef can work pretty well, but it can be intimidating to someone who comes from maybe more the admin side and just wants to say like, nope, I don't care. install these 6 packages on my system, and that's what I want.
It seems like there's a lot of great options, but it also seems like this could be sort of vital for my sanity.
Yeah, we've been talking about why you should use configuration management, but I think in 2018, it's more like, why aren't you already using configuration management? Honestly, at least when I think about it in a production corporate setting, if you're building a new server and you're not putting it in configuration management somehow, you're really just being negligent. You're building a one-off system. It's going to be harder to troubleshoot, and if it breaks, it's going to be harder to repair.
So this being an introduction, let's talk about small business for a moment, because I think maybe I'm at that threshold. And so I want your consultation, Wes. How far down the rabbit hole do I go? What's sort of good for say a half a dozen servers and a dozen workstation management?
You're right in that gray zone. I think many systems could work for you, but probably Ansible is going to be a reasonable fit, just because it does have the lowest barrier to entry. You don't have to set up a centralized server, although they do have some options now. Ansible Tower is now open source. It's not something I've played with a ton yet, but maybe something we'll cover more on in the show. So Ansible has a lot of options. It's very flexible, and you do already have SSH infrastructure set up. Some considerations, Ansible can be a little bit slower sometimes in that it does have to use SSH connections, where some of the other systems have faster setups.
Would it be fair to say that if I'm a larger enterprise, I might want to look more at some of the agent-based systems?
That has been a complaint of some larger organizations, but for anyone doing small-scale stuff, medium-scale stuff, if you have time to wait, it'll work just fine.
Okay, that's kind of what I'm thinking. So this might be the path I start taking, and I know there's an angle for desktop users as well.
Yeah, that's right. We think a lot about doing this on the server, but it can configure desktops just as well. It doesn't really matter. And Ansible actually has a lot of different modules that may be useful, things like dconf even.
In fact, we got an email into the TechSNAP program about that very thing. TechSNAP.ting.com. It's a smarter way to do mobile. The average Ting bill is just $23 per phone because it's pay for what you use wireless. A fair price for however much you talk, text, and data you use, with nationwide coverage and no contracts. Ting isn't about locking you into a commitment. They're about letting you be flexible. Try out Ting risk-free. Go to TechSNAP.ting.com. You get a $25 service credit if you bring a CDMA or GSM device. Just check their BYOD page. Or you can buy a device from Ting and they'll take $25 directly off. They also have SIM cards that you can get just starting right there at $9. You grab the SIM card and then you'll get $25 in service credit. Pop that into a security system or maybe a device you're working on. There's lots of great options. I have a couple of friends now who use these on their home security systems as a backup connection. $6 a month if it never uses the connection, and if the main line goes down, which has actually happened. Sometimes it's not even just like a physical line that goes down, but it's like an IP outage. And these security systems will back up to the SIM card and start broadcasting imagery and video. And you only pay for what you use. They have lots of great devices you can buy directly or bring your own. TechSNAP.ting.com. Thanks for sending your feedback to techsnap.systems/contact. Jay writes in and tells us about his Ansible setup. He says, I wanted to mention that I've been using Ansible to accomplish desktop management to great effect. I like Ansible because there is no agent requirement. Interesting.
Hey, yeah.
He says, for me, I've configured Ansible to do everything. And I mean everything. For example, it installs GNOME, it sets my wallpaper, it applies my GTK icon themes, it sets my keyboard shortcuts, etc. It also sets up my SSH keys, my user.files, my OpenSSH configs, and much more. There are two ways of setting up Ansible. The first method is the standard. You set up that central Ansible server, you curate an inventory list with all the different IP addresses. The second is you set up a Git repo for your Ansible playbooks, and then just git pull and run them against localhost. I do the second method, because my laptop, for example, may or may not be online when an Ansible server goes to connect to it. I have a bootstrap script written in Bash that installs Ansible, does the initial git pull, and then proceeds to provision the machine. Then, anytime I wish to synchronize my configs, I run the provision script again, and it pulls the latest configs and applies them to the machine. I have several roles, including workstation and server. Which role I put the machine in determines which config it gets. Jake concludes by saying, hopefully this inspires all of you to use configuration management, even for the desktop, Wes?
Yeah, exactly. I think this is a great example. And he has a really good point about, you can run Ansible in multiple ways. It is common to sort of have a central server or workstation where you then push out changes to your nodes, but you can also set up a cron job or just do it whenever you need to, have it pull down from a Git repo and just run Ansible locally.
What about for me, what about for my DigitalOcean droplets? Because I feel like that's another area where I could use some configuration management, and I would even like something that just talks to DigitalOcean's API and sets the whole shebang up for me. Is that going to be possible?
Yes, it absolutely
is. Is that something
Ansible does have integrations with DigitalOcean's API, so you can have it both spin you up additional nodes and then provision them.
And configure them for whatever I might need. Yeah. A new streaming server if we need additional streaming bandwidth.
Yeah, exactly. Or if you already have one, you realize, we really need that second one. You already have the config made.
Oh, man.
And I think Jay makes some good point. He's doing everything, and you can get that way, but you don't have to. So he's talking about dot files here. You can start with having Ansible just as a system that, you have a Git repo with your Ansible configs and dot files in it, and it just deploys dot files, right? So you can start somewhere small like that and then just add more things, right? As you install new packages, do it with Ansible instead of doing it on the system, and then you've just made it reproducible.
That is really appealing.
So you really don't have to spend a whole day. You don't have to redo your complete system. You can just start adding things in. Take it easy. Once you've got a little bit of the learning hurdle over the way, I think you'll really feel empowered.
Well, that wraps us up for this week's episode of the TechSNAP program. You can follow the whole network at Jupiter Signal on Twitter. Also, grab new episodes of TechSNAP every single week, techsnap.systems/subscribe, for all the ways to subscribe and to get the RSS feed. And last but not least, we'd love to get your feedback, your questions, your emails. Go to techsnap.systems/contact, and we'll see you next week.